In today's world, safety is not just a priority, it's a necessity. Industries across the globe, from transportation hubs and schools to corporate offices and public events, are adopting intelligent surveillance solutions to detect threats in real time. Using computer vision, we can train vision models to identify dangerous objects, like firearms, instantly and accurately. This means security teams get faster alerts, quicker response times, and ultimately, safer environments. Whether it's preventing incidents at airports, enhancing safety in schools, or securing large-scale events, computer vision-based detection systems transform surveillance into proactive protection. The result? Reduced risks, smarter decision-making, and peace of mind. In this tutorial, I'll show you step-by-step how to fine-tune YOLO for firearm detection, so you can build security solutions that truly make an impact.
Hello everyone, welcome to this tutorial on computer vision in which we are going to fine-tune YOLO for threat detection. To do that, you have to simply follow some steps. Our first step will be creating a data set and annotating it. So we will start by creating a data set. To create a data set, you can gather various images of threats like gun from the internet. You can use Kaggle, Hugging Face for your purpose also, and then you have to annotate your data set using gun class on tools like Labeler. Let's go annotate that data set. For the purpose of this tutorial, I have created only gun class as a threat. You can also create various other classes of threat like violence and etc. So we start by labeling the gun class in the image using Labeler platform. We use bounding boxes for that and submit our. Similarly, we do this for this image also. We will keep repeating this process till all of our data set has been annotated and ready for YOLO training. So when our data set has been annotated, let's get to our next step. For our next step in fine-tuning YOLO for threat detection, we have to convert the data set we have annotated in a COCO JSON format to YOLO format for model training. So to do that, we just have to clone this repo. After that, you have to provide the JSON part, which is the annotation in COCO JSON format, and the image directory in which all the images are stored, and the output directory name, and run this program. Now our annotation and data set has been converted into YOLO format from COCO JSON format. So our next step is to train that data set on our YOLO model. So to do that, you have to install UltraDirectX library, and from that UltraDirectX library you have to import YOLO. Let's do this. Now our next step for training is to use this command line model of YOLO, in which we have to provide task equal to detect, mode equals to train, and data will equal to the parts to the dataset.yml file, which is in the YOLO format folder, and provide the model name also, and how many epochs it will run. I have done this command line. It took me 2 hours to complete my model training, and created a folder called runs, which is this folder. This folder contains my trained model in .pt format. So let's get to our next step and see its inference result on a real world scenario. As our model has been trained, we can also validate our model on a test dataset like this. This image shows the result of our model inference on various case scenarios like this. Let's see our model result in a real-time video. For that, you have to just use your model part here using YOLO function, and then use that model on a per frame using OpenCV. Let's see our result and similar result also. Now you have learned how to fine-tune YOLO for threat detection. You can use this similar steps to create a model for detection of various other threats like arson attacks, violence, and intruder alert. So let's see you on our next tutorial.
For more computer vision or machine learning related tasks, you can check our GitHub, where you will find everything in one place.